Assalamu alaikum wa rahmatullahi wa barakatuhu, and very good morning. We are in the last part of our Unit 1. Okay, so far we were discussing many topics on Unit 1. Today we will review whatever we have covered in the Unit 1. Okay. In the Unit 1 we have started with the introduction. So what is engineering mechanics? What is the need for studying engineering mechanics? Okay. So mechanics, mechano means machine, but mechanics is used, mechanics, that word is used to lift, okay, to represent the lifting of weights. Lifting of weights. Okay. In the ancient days, they have to lift many heavy weights in order to build giant structures like pyramids. So they were worried about lifting of weights, so they used machines. So what is the first machine invented by the man? What is the first machine? No? Lever mechanism. Crowbar and lever. That crowbar lever mechanism is the first machine devised by or invented by mankind. Okay, the wheel came later. Okay. So that lever is mainly used for lifting of weights. So that we have discussed the history, how it was evolved, engineering mechanics concept from our Newton to many other scientists, mathematicians. They have all involved and developed the theory of engineering mechanics. There is different classification of engineering mechanics. Remember, what are the classification? Classical mechanics, then quantum mechanics. What is the difference?
Solid object.
Solid object need not be. The particles are considered greater than atom. Then if the size is larger than an atom and the speed is less than the speed of light, it is classical mechanics. Okay. If the size is approaching the size of atom and the speed is nearing or approaching the speed of light, then we call it as quantum mechanics. The classical mechanic approach cannot be used for a particle which is of very small size, nearer to the size of an atom, and the particle is considered to be moving at very high speed, nearer to the speed of light. So the classical mechanics will become insufficient to explain the properties of such a particle. We have two classifications, two parts, statics and dynamics. The equilibrium of particle when it is at rest, that is statics. When it is at motion, effect of forces on a body at rest is called statics. Effect of forces on the body at movement, dynamics. Okay, so we have two parts again. So in the statics, we have started with definition of a force, how the force is represented as vector. Why we have to represent force as a vector? It has the three properties: magnitude, direction and sense. So any quantity which has got magnitude, direction and sense, we call it as a vector. So force is a vector. So we should know the basics of vector algebra. So the scalar of the force is magnitude. Okay. Vector we can go for Cartesian vector representation. So we consider force how we resolve it into two components by using parallelogram law and triangular law, sine rule, cosine rule, to get the numerical values of the resolved components. So we need to resolve the forces in order to analyze a system of force. In general, if you have many forces acting on a body, in order to get the net effect of the forces, we have to resolve the forces to the axis, which is easier for us. So in order to resolve the forces, there are many approaches. The parallelogram law and triangular law we have solved graphically, and for numerical approach we used cosine rule and sine rule. Okay. So that then if there are many forces, the parallelogram law will become difficult to approach, difficult to apply. We have to use the Cartesian vector formulation, the unit vector concept. So this portion we have covered initially. The numerical solution is obtained by using sine law, cosine law. The graphical approach by parallelogram and triangular. Okay. And suppose if there are many forces, in order to analyze the system of forces, we consider the condition of equilibrium. Equilibrium at rest. Okay, now it is statics. So the equilibrium can be of two kinds again, as we told, static and dynamic equilibrium. In static equilibrium, your force becomes zero because no velocity, and in dynamic equilibrium, force becomes zero because velocity is constant. A becomes zero as V is constant. Okay, if there is no change of velocity, rate of change of velocity is acceleration. So velocity is constant, acceleration will become zero in dynamic equilibrium. So here we are bothered about static equilibrium, and under static equilibrium conditions, the forces, summation of the forces will be zero, or the resultant net force will be zero. So if you find one will be like this, the other arm will pull. One will push, the other will pull. So the force is applied in the opposite direction. Okay, so this is due to, this is coupled. So you apply a couple, the couple develop a moment, that is why your steering wheel is rotating. So moment of a couple is, an example for a moment of the couple is how you apply, how you turn the steering wheel. Okay. Okay. So the last topic we have covered is about moment of a couple. So if you apply moment, if you apply the force along the arm, along the wrench, no moment. Okay, it should be perpendicular to the wrench, perpendicular to the line of action of the force. So if you apply force like this, no moment at all. Okay. So this and this distance should be perpendicular. D. If you take smaller d or incline like this, you have to do more. You have to apply more force, or it will be difficult to turn. It will be difficult to turn. Okay. Then in order to represent the moment, cross product is used. So dot product, forces. Okay. Forces, their angles between the two forces or two vectors can be found by using dot product. In order to represent the moment, we use cross product. The vector representation of the moment is obtained by using the cross product approach. Okay. So A cross B equals to another vector C. If you remember, A dot B is not a vector. A dot B is a scalar. Okay. Whereas A cross B is again a vector, vector C. So if you have two forces, or if you consider the force and its distance from O, position vector and force vector, so the cross product of position vector and force vector will produce another vector which is called as moment. So we use the cross product approach to represent moment. Like, so this is the Cartesian vector form, and moment is represented by force and its cross of R, the cross product of R, position vector. So R cross position vector R cross the force vector will give you the moment M naught, moment about O. So it can be represented in the matrix form for Cartesian vector. Okay. I, J, K are the unit vectors, Rx, Ry, Rz are the position vector of magnitudes, Fx, Fy, Fz are force vector magnitudes. So with that we covered most of the topics in our unit 1, and we will see now. We will see some of the review problems now. Okay. So this is the first problem we are going to see. So there is a log. It is pulled by two tractors. The force is given. Resultant force is given. And the angle theta is also given. The same problem we did in another exercise, isn't it? Do you remember? The two boats, they are pulling the log. We did the same problem, but in order to have more exercises, I am giving this exercise. So how will we find out forces FA and FB? Resolve the resultant into two forces FA and FB. Okay. So in simple cases like this, you can use cosine rule or sine rule or parallelogram law. Okay. The resultant is given. Its magnitude is 10 kilonewton. It is directed along x-axis. Angle between the resultant and FA, FB are given. FA is 30 degrees. FB is to be taken as 15 degrees. Set theta as 15 degrees. Okay. So you draw the parallelogram. Find the unknown angles. The angle included in the parallelogram will be 360 degrees. Opposite angles are same. Okay. So this corner, the tails of the two forces, they make 75 degrees. 45 degrees. 30 plus 15, 45 degrees. So the opposite corner will also have 45 degrees. So 360 minus 90 will be the remaining angle. You divide it into 2 and put it in the diagonally opposite corner. So we got all the angles. Now we can apply the sine rule to get the unknown forces. Okay? So draw the parallelogram. So these problems are taken from Hebler. Most of the problems as I informed.